Good evening, or even good morning, ladies and gentlemen, wherever you are around the world. Thank you for joining us today on this Logistics Business live stream, coming to you on LinkedIn and YouTube. It's a great pleasure to have you here joining us today. Thank you very much for taking time out of your busy schedules. My name's Peter McLeod. I'm the editor of Logistics Business magazine. As always, it's a great pleasure to host one of these. First time we've done a live stream like this before, and of course I couldn't steer the ship on my own. I've got with me, alongside me, is not exactly how we would describe things in this technical digital age. Somewhere out there on the other side of the internetosphere, we've got Glenn Aspenns, who's the portfolio manager at Honeywell Productivity Solutions. Hello, Glenn. How are you doing?
Good afternoon, Peter. I'm doing well, thank you. How's your day going?
My day's going well, thank you so far. How about what about telling us where exactly you're physically located currently?
Yeah, so I am located in Cincinnati, Ohio, kind of in the center of the Midwest of the United States, so a
Hmm.
little ways away from where you're currently located.
Yeah, great. Well, I'm in Central Europe. I'm in Warsaw in Poland. So we have a truly global audience today. So we're going to keep the chat very relevant, very industry focused. Um, we're going to talk today about the years old technology of barcode scanning has got has had a little bit of a revolution of late with the introduction and the incoming of AI. So we're going to be talking about ways in which AI has brought scanning back to the fore again in warehouse operations. I think you can probably guess I'm just holding on a little bit before we get into the meat of things here, just waiting for a few more of you to join us. But let me just read out my little prepared intro before we jump into the subject, and then I'll let Glenn launch into the subject. So, I mean, you could say, here we go again. It's another webinar. It's another podcast. It's another presentation about AI. So, what more could we possibly say about it? Well, listen up. There's a lot here that you probably wouldn't have heard before. I've never heard it before. It's very relevant for all of those of you out there who've got any element of scanning going on within your warehouse operations. Basically, all of you, right? So AI it dominates almost every technology conversation today, but separating genuine operational improvements from that marketing hype is not always easy. Barcode scanning is hardly, shall we say, a glitzy technology. I don't want to do it down here because I know what a critical part it is. But you know, it's a foundation of the modern logistics operation. But we're going to explore today in this live stream for about the next 45 minutes or so how AI is actually changing barcode scanning in as much as it's going to deliver a more measurable value today, where it, you know, and particularly maybe have a little look and see where it doesn't, and we'll also learn what what you out there, you know, operational leaders, operators of warehouses should be looking out for when specifying AI related scanning products. So maybe Glenn, if I could kick things off by asking you about why barcode scanning, under the general banner, why barcode scanning still matters. You know, people have been scanning barcodes for decades. So why is it still such a critical technology and so important in 2026?
Yeah, it is interesting, right? When you think about what barcoding basically does. So, we started back in, I guess, 1971 around kind of the foundations of modern barcoding. I think the first barcode was scanned in a grocery store in somewhere in Ohio here in
Ah,
1974,
beautiful.
a package of juicy fruit gum, right? But basically, barcodes are it's the linkage, right, between the actual physical world and the virtual world or the computer world. So to the extent that this today, it's been widely deployed. It's absolutely critical in logistics industries in particular. Basically, when you're trying to track a physical object into the digital world and identify each of the touch points, you want to know where it's located, at what time, where the interactions took place. And this is basically that bridge between the digital world and the literal world. And there are a lot of other technologies that people are looking at in terms of machine vision, in terms of RFID, other kind of competing technologies. But in many cases, those are a complement to traditional barcode scanning, which has a number of notable benefits in that you get very positive ID, you're getting direct line of sight verification of the item that you're tracking. And so yes, it is still hyper relevant to the industries where we're operating today.
Yes, of course, and it's not just sort of within the four walls of the warehouse, as we know. Those of us who, all of us again, who go out and buy stuff. I mean, what do you think would surprise people about, the number or the proportion of business decisions that still depend on successful scanning?
So it's the vast majority. If you buy a product, if whether it be in retail or e-commerce, if you're tracking an item that's in a warehouse, they're almost all identified with barcode first. This is that critical link that helps you identify what you have it, where it's going. It's interesting when you look back at kind of the improvement in e-commerce, in warehouse and DC logistics. A lot of those improvements, people used to get wrong packages, wrong items all the time. Now it is vanishingly rare. When you order something, you expect to get that thing. When you buy something, you pay that price. And all of these connections are facilitated via barcodes. And that's where we're looking. I think the adoption is extraordinarily high. So today it would be rare to walk into a facility and find people are still operating on pen and paper and there aren't barcodes that are being used to track things. So the challenge is, how do we identify what the next steps of improvement are? How do we carry this forward to the next level? That's some of the ways that we're seeing the current conversations around AI becoming really interesting.
I guess, of course, the real world is so different to laboratory conditions. When you're designing scanning technology, and when you're printing the labels themselves, if you were to do that in a laboratory, you'd get 100% accuracy. But out there in the real world, you've got very many factors that conspire to make it very difficult to get 100% accuracy in scanning. Could you maybe sort of highlight some of the issues that contribute to that challenge?
It's interesting because I think a lot of people kind of see that, like we were talking about, this is a fairly mature technology. When people think about barcoding and how it operates today, people think this is a problem that's been solved. We know how to read barcodes. And again, in the laboratory, yes, it you can print a great barcode and you can scan it all day long, but real world conditions tend to be very different from what you see there. And there are a lot of things that go wrong. I think one of the first is just barcode print quality. So if you set up a printer, you get it calibrated, you get it operating, and things are looking great, the barcode contrast is great, your modulation, your symbol contrast, everything's beautiful, right? But run that printer for a week, a month, a year, and you get breakdowns in the print head, you get buildup on the print head, you get ribbon wrinkle, you get barcode media, the media shifts and suddenly your quality output's different. So just the baseline of consistency of the barcodes that you're reading is one of those challenges. Anyone who's working in a warehouse environment knows how common it is to have stretch wrap on these products, and that can create not one but two unique problems. So some folks will apply the stretch wrap over the barcode labels. And at this point, now you're introducing the opportunity for glare. When the illumination hits it, you're getting reflected and blinded, and it makes it difficult to read with the scanner. The other problem that you commonly see is as that stretch wrap wrinkles, and particularly you may have a beautifully wrapped pallet that's getting ready to leave your facility, and now it goes through transit and it's rocking on the vehicle, and then it arrives and it may go through two or three logistics stations before it arrives, and it tends to shift. And that stretch wrap is shifting and wrinkling, conforming, and you end up with distortions in the barcodes that now the scanner needs to understand. It's no longer the lab perfect barcode label. So I mean, those are just a couple of the really common ones that we have: just print quality, stretch wrap impacts, um, low light conditions. You're
Yeah,
reading
yeah.
in a warehouse and you may be reading outdoors on the dock with direct sunlight, maybe reading inside the warehouse with very low lighting. And all of these add significant challenges to the functional performance of reading those barcodes in those environments.
And I guess the barcode isn't presented face on at a stationary angle to the reader. So you've got stuff. If I use a technical term, whizzing past, I would say.
Yeah, yeah.
So yeah, adds further complications there. So we're trying to scan in suboptimal conditions here.
Hmm. Yeah. Well, and you're talking about the angle. One of the ones that comes to mind is, particularly if you're reading in the warehouse and you're reading as you're either pulling product from the fork truck or placing product, you're reading at an angle at the barcodes that are on the racks, and it's almost invariably at a pretty crisp angle. And secondarily, you have the complications of background lighting, which can also contribute to blinding the scanner if it's not able to handle that. So yeah, there are a lot of issues that you can run into in the real world.
So I guess the sort of physical technology, the hardware, has tried to compensate as much as it can to overcome some of these issues. But you cannot always change the environment in which they have to operate. So
Yeah.
I guess that's the challenge there as well. So let's bring it on to AI then. This it suddenly becomes our friend. AI can sort of enhance some of the inadequacies that, or shall I say, overcome some of the inadequacies and enhance some of the parts that can't be read so well. Can you
Mhm.
talk us through the introduction of AI into barcode scanning?
Yeah, absolutely. And it is interesting, right? Because as we were talking, the barcode technology has been developing for many years. We had traditional 1D barcodes, where it's literally a laser illuminating the barcode, and you're tracking the physical binary response, whether it's a black bar or a white code, right? And all of this is we've been marching the technologies forward. There's been tremendous development in optics and sensors and the kind of the zoom mechanism for long range scanners and all of these things. There's been a ton of work put into the physical hardware, but now we're getting into the AI implementation. Now we're starting to expand all that and layer on top of those other core technologies. And this is starting to open up new capabilities. So functionally, there are things that you can do with AI technology, with the implementation of neural processors towards solving some of those problems. So if you look at some of these corner cases that we were talking about, where you have difficult to read barcodes, low quality barcodes, barcodes that got damaged in transit, now you can start putting pieces together and coming up with quick solutions. So just as an example of a way that you can address this, where you're again, not just implementing a buzzword for the sake of implementing a buzzword, but trying to focus on dropping productivity gains to the customer's bottom line. Now you can start doing things, getting the scanner physically operating smarter. So, for instance, now you can survey an entire field, and rather than the algorithm bouncing around on that field of view, and looking for barcodes that are not optimally located, which is very common in the real world. Now you can take a first pass, identify using machine vision and AI, you can identify exactly where the barcodes are. And now, even if they're low quality barcodes, you can focus all of your time and effort on where they're actually located instead of not getting a read and bouncing around everywhere else. And this is kind of one of those things that's interesting about the implementation of the marriage of that technology, is that now you've got the capability to work much smarter. So um, basically, again, we're all focusing on improving productivity, reducing those bottlenecks, reducing those instances where you're getting a slow scan or a no scan. The scanner is functionally reading many times per second, and deciding which of those frames is the most promising and which locations are the most promising. That's one of the key areas where AI is engaging, and we can see net benefits in terms of productivity, just as an example.
So you've used the word smarter there, which it does get bandied around a bit. But maybe I can ask you to
Mhm.
define what smarter means. I think you've already touched on the fact that it's you're effectively increasing accuracy or read accuracy. Is
Mhm.
there also a benefit there in speed of scanning too?
Yes. Yeah, that has been a really big one. So most of our customers, when they're when they're looking for scanners, they're not necessarily saying, I've got to have a scanner with AI because I want it to compose emails for me. They're saying, I want this to read faster. I want to eliminate bottlenecks in my operations. And so everything that as we go through and develop, everything that we've done has been around dropping those productivity benefits. So for instance, one of the ways that we're operating smarter is it's all geared around that read speed. So when we're benchmarking products, we set up basically test boards. And as we're engaging with customers, it's very real world focused. It's very identifying those pain points focused. So as customers provide us, they say, hey, we're having a problem with this particular mark, this particular code. How can we help with this? So we take those and we basically compile test boards of these corner case and difficult to read barcodes. And we run the scanners through multiple users and basically time the speed of scanning everything that's on these boards to identify when we're making tangible improvements to that. One of the things that we've found when we do these tests, we get the benchmarks, we get the results, then we provide the physical product to our customers. We've found historically that if you're seeing about a 20% in our benchmark testing, if you get about a 20% differential between product A and product B, that is when the people who are actually working with these scanners all day, that is the threshold where they will reliably detect this scanner is better and faster than that scanner. And with the latest implementations, we implemented faster processors and upgraded algorithms and integrated AI into the process. With the latest generations, you're talking about or asking about the speed, we're actually seeing a 45% improvement in net scan speed, which is it's huge. It is a step change. And when we apply those same technologies to long range scanning, which is kind of a different set of challenges, we saw a 60% improvement in speed. So this is not marginal. This is not kind of tangential. This is not diminishing returns. We are seeing step changes in capability with the implementation of AI into those scanning technologies.
And of course, that the speed of reading is a fabulous enhancement to what we were benchmarking against. But of course, first pass read rates are significant, are very important. Can you explain what first pass read rates, why they're important, and where AI can again help enhance those?
Mhm. Yeah, so it's interesting. Basically, the person who's holding the scanner, the person who is operating the process, that driving the fork truck or packing the boxes or picking or any of these common workflows, they're going to perceive if the scanner doesn't read. Basically they pull the trigger and it's not reading, they're moving the scanner in and out, they're trying to get the distance there, all of these things that are adding inconsistencies to the process. That is what we're talking about. And when you pull the trigger and it reads instantly, that's the goal. That's what people want to see, and that's what we're talking about with first read rate. And so the customer perceives this when you're using AI to view the entire field of view, to identify where that barcode is, to point the algorithm directly toward it. You're operating faster and more efficiently. And to the user, it's just perceived as instant reads. And one of the things that was, I think, interesting about this, so we've done, when we're doing our benchmark testing, we took, it's kind of operating across this continuum of capability. So we took, um, our core algorithm and we ran it with AI on and we ran it with AI off just to see what happens to this continuum. And this was testing conducted across a range of really, really difficult barcodes, things that are absolutely marginal on the cutting edge of it won't read at all. And so we saw, when we're talking about speed, we saw across this continuum, we saw barcodes that would not read at all without AI on, that read now with it on. And we saw everything across this continuum from slow reads to fast reads shift to the right. So the set of codes that would read just instantly as quickly as you pulled the trigger were dramatically increased. So there are big changes, and again, it's across that continuum from the very difficult codes to the ones that are easier to solve.
So these failed scans can cause a cost to the business. They can cause
Mhm.
operational issues. There's no point having data if it's bad data or missing data. So what's the difference that, for example, a missed scan can make to a business? And I guess this is the problem that AI is coming in to fix, isn't it?
Yeah, yeah, absolutely. So when you look at kind of how you're solving that problem, right? What is the crux of it? So when the barcode doesn't scan, and it's again, it's operating across a continuum that I think your your readers and your viewers are seeing in their operations, and they may not even be noticing. So kind of on the best case scenario, I hold the barcode to the scanner and it doesn't read immediately, right? So the immediate effect is, okay, I'm playing with angles, I'm holding the trigger down, I'm trying to get a good read, and okay, beep, now it finally went. So it seems that this is kind of a limited effect, but functionally it erodes the throughput across the operations. When things work reliably, they work at high speed, people get accustomed to operating at high speed. When their reading is unpredictable or slow, then they slow to compensate for that. So if I know there's a good chance it's not going to read immediately, now I'm taking time expecting to see those pain points, right? So that's kind of on the best case scenario. That's what you're going to see. If you extrapolate that out to the worst case scenario, which is this barcode physically won't read, so now I've wasted 5, 10 seconds trying to get it to read before I finally gave up. And now the fallback is usually, in most cases, manual data entry. And that's exactly the problem that barcodes were designed to address because all of the negative effects of that. So manual data entry, it's dramatically slower. You need to walk to the keyboard or use your device, and now you're doing manual data entry. But the bigger pain point when you're talking about data integrity, the bigger pain point with manual data entry is exactly that. So I've heard a few things bandied about in the industry, but most commonly, I've heard about a 1 in 300 error rate. So if you have a 10-digit code that you're entering and you do 30 of those, now one of those is going to be wrong. And now you got bad data feeding into the system and all of the knock-on effects for inventory accuracy or incorrect shipments or all those bad things. These are all direct results of not having effective scans. So when you can implement this technology, when you can take a no read and turn it into a read, that's huge. That is a tremendous benefit. On that topic, one other kind of quick thought. There was a super interesting story. I don't know, did you catch the story? I think it came out earlier this week about AI breaking its bounds. And there was an
Yes.
AI model that was supposed to be sandboxed, and right? How do we make sure that we're not going to have extrapolations or hallucinations or introductions of bad data into these processes? And that's why we've really focused our implementation on using AI to solve operational challenges and problems around the decoding process. But we're continuing to use for the actual data generation, we're very intentionally using the core algorithm that we've been honing for 30 plus years, which gives high speed results and high accuracy results. And then implementing the neural processor, machine vision, AI capabilities around that so that you are getting reliable data. And I think that is an important consideration as we're applying these new technologies to solve these problems, if that makes sense.
Yes. It certainly does. Now, I want to apologise to our viewers, listeners. I didn't say at the beginning that, of course, this being a live stream, you've got the opportunity to throw questions at Glenn, catch him out if you like. And I'm delighted to say that you managed to work out for yourselves how to do that through the chat function on this, whichever facility you're watching this through. So I've got a couple of questions here that have arrived, Glenn. I'm going to throw at you at random
Okay.
and see how we get on with them. First one, can AI identify and verify an entire mixed palette from a single camera image, or does it still require individual barcode scans?
Yeah, so this is interesting. This is one of the big benefits, and I mentioned one of the capabilities of machine vision. You can look at an entire image and identify where those barcodes are. And this is one of the capabilities that I think is really, really interesting because it creates the opportunity to rethink that workflow. So if you have a barcode scanner that can read every one of those barcodes basically as fast as you pull the trigger, it still requires you to point the scanner and pull the trigger and watch it beep on all of those. Now we've got the capability to look at that entire field of view, identify all of those barcodes, and then output the data, which is, it really does open these types of workflows up. It's transformational. It's not just I'm reading 45% faster, but it is I'm reading 15, 20, 40 barcodes at one time and outputting the data. It does require that on the host side, you know how to interpret that data. And there actually is a kind of stunning amount of capability. If you have a general idea of what you're looking for, some of that can be done at the edge where you can identify in the scanner, here's what I'm looking for. So if I've got 15, 20, 40 barcodes, I want them outputted in this format, that can be done on the edge in the scanner. But beyond that, in many cases, if you're just getting a straight data dump of a mixed load palette from multiple vendors and different SKUs and different formats and so on, that level of complexity is definitely something you need to have a mechanism for sorting out and making sense of everything that's in there, if that answers the question.
It sounds to me like it does. It was a great question. Another good question has come in also here. We talked about some of the sort of the fundamental speed improvements. The question here is, what percentage improvement in inventory accuracy have customers typically achieved after implementing an AI-powered vision scanning solution?
Yeah, so I think the calculation comes in basically layered on the key stats that we're talking about. So if you look at reducing the number of no reads, and this is going to be contingent on the quality of barcodes and the environment and so on. But if you're reducing that quantity of no reads that have to be manually data entered, this is going to vary wildly by enterprise. So if you can look at your data, identify how many are being manually entered, assume that 1 in 300 error rate, that will directly drop to what that is. And once you can implement it, reduce that number of no reads. And like I said, it's been substantial in what we're seeing. I'm trying to recall off the top of my head what those stats were on the no reads, but I think we had a roughly, I think it was a 30 or 40% reduction in straight no reads. So every one of those now multiplies by that 1 in 300 error rate, and that should give you a pretty good indication as to what the improvement will be for implementation in a typical warehouse.
Um, yes, you can tell that was an unprepared question because you didn't quite have all the data to your fingertips there, but we like to see that. More questions,
Yep.
please, from the audience. So what you're saying, Glenn, is that AI can help sort of compensate for some of these real world situations that we find out that we come across in the messy world out there. So that compensates for poor labels, those awkward angles, I guess, and the damaged packaging. So we can overcome all or most of that.
Yes, yeah, and what you're seeing is improvements in, again, reductions in the no reads, but you're also seeing the improvements in the speed of reading. So rather than I'm having to sit and focus and move in and out and trying to find the right angle, it's much, much faster at optimizing all of those things that create a good image, and then optimizing the interpretation of that image once it's captured.
So I want to maybe step away from very specific scanning conversation and maybe just talk about sort of separating fact from fiction when it comes to AI in general. I'm no different. I think we've all become slightly skeptical when we hear sort of AI powered something described as that or written about using
Mm-hmm.
those terms. So what should buyers actually be looking out for when they're looking at suppliers? And how do these sort of separate the sort of meaningful innovation in the AI world from what's basically clever marketing, shall we say?
Yeah, yeah, absolutely. And I share your skepticism, right? It's commonly bandied about, and I think the greenwashing of a number of years ago has become the AI washing of now. and and everybody wants to put it in their product or talk about it in the product. And uh, yeah, in terms of making sure that this is actually conveying value to the operations, I think that that's one of the core areas. One of the first things that I think is worth asking is, how do I test it? How can I put this in my environment, verify that I'm actually seeing the benefits that you're talking about? That's a big one. I think one of the other ones is just verifying what is the net benefit, what is the claim, how is it qualified, right? So that's a really important factor to consider. So if the claim is up to, right, then you think, all right, that doesn't mean I'm not guaranteed this number. They're proposing that it comes up to that rate. And then you put in your operations, you can verify, am I actually seeing that, or is this something much more subtle? um, I think the other thing that you'll want to look for is just, I suppose, credibility in the environment. So again, a lot of people can make claims, but if you have experience, if you have years of deployment, I think that that really helps bring that credibility to those claims. So those are a couple things off the top of my head that buyers should be thinking about. I think, like you, I think a lot of people are skeptical, and having, again, really understanding what is the claim, what are we talking about, how is the data baked in for building out that claim, and then is this something that I can physically test in my operations to verify that I'm going to see those same improvements. I think those are probably three big things that you'd want to consider.
Chris is asking, does the machine vision scan the barcode in the traditional sense, or does it simply read the data in text associated with the barcode, i.e., the GTIN?
Ah, yeah, okay. So the kind of march of technology has progressed, and I touched on this briefly at the start. So originally, this was all about lasers that are physically tracking across a barcode, and then you've got kind of a solar cell or like a photovoltaic cell that is turning the reflected energy into a signal that says, oh, oh, that's a wide bar and that's a narrow bar, and so on, right? So now the technology's really moved toward 2D. So if you think about it, your modern barcode scanner today is functionally a camera. And so you're capturing an image of that whole scene at one time. So you're managing exposure and you're managing motion rates and and illumination, all these other pieces, focal length, to capture a good image. Now that image is what the decoder starts working on. And like I said, with the machine learning layered in here, it is helping identify where in the image the key areas of interest are. Then your algorithm works on that code. And in many cases, you're looking at evolution or adoption of 2D code. So rather than just a traditional vertical barcode, now it is more of like that checkerboard data format that it is being extracted all at one time. So it is very different, and but the functional process is very similar. You're surveying the scene, you're identifying the barcode, you're capturing the data and feeding it out. Now, when you talk about GTINs, I think that was a really interesting topic. So as we're looking at Sunrise or Ambition 2027, we're starting to see migration, and there are a few different areas that GS1 is highlighting for improvement. And this is something that I think we're all going to be seeing increased adoption over the next few years. So traditional barcodes, the G10, or what many people used to refer to as a UPC, was a traditional 1D barcode. So we're going to see this migration to where we'll see first that 1D barcode plus a 2D barcode beside it. So now we have to determine what to do with that. And there are several different functions, and this is all, again, processing at the edge. But as you define what you want your scanner to do, you can accept either. You can prioritize the 2D code. You can make a lot of these definitions as to how you want to operate. But there again, you've got the intelligence operating at the edge that's defining how you want to pull that data out. And I think the key benefit that we'll all be seeing there, I'm just thinking in terms of current events going on right now. I don't know how global this has gotten, but in the United States right now, we have a an outbreak that has been tied in some cases to some types of lettuce in some regions. And so right now there is a big effort being tracked to identify the root, and this generally leads to recall events and containment and
Mm.
control and all of these types of things. And it's happening today in the U.S., but these are things that happen all around the world. So
Classic
one of the
supply
things that's,
chain sort of story.
yeah, exactly. And the really interesting thing about this implementation of these of the new G10 or the new GS1 standard is that in that 2D code you can start collecting more data. So now rather than just the UPC, now you can have lot data, you can have source data, you can track this back to where was it grown, where was it harvested, where was it processed, and you're starting to get some of these real safety benefits that drop in. And again, as you're looking at how when you get machine learning, vision systems, AI intelligence in speeding the process of reading these more complex barcodes, now it's easier to implement those into those workflows.
Well, I hope that answered your question, Chris. It certainly opened up a whole new area there. Um, so sort of maybe just finishing off on the sort of separating fact from fiction, or maybe buyer beware. What claims should make buyers cautious? What can't AI fix in this world currently?
So I think one of the things to watch out for is self-learning, because again, as we talked about, one of the risks with AI is that it will wander off and do something unanticipated, right? There is risk associated with that. And so I think one of the things that's worth considering is if we're claiming that this device is going to continuously improve its intelligence as it operates, then there is risk that it is going to wander off and do something bad. That it's going to start extrapolating data or introducing inaccuracies and so on. And again, that's something that in our design philosophy, ensuring data integrity is premium importance, and functional speed and benefit is really, really important to how we're operating. So I think beware of claims that this device is going to continuously get smarter and smarter and self-optimize. I think that's something to be concerned with. So when we look at the way that we've approached this, um, there's been a heavy focus on training with a vast database to ensure that we understand what's happening, we understand the outputs, and we can control those benefits that get loaded into the algorithm that then runs on a neural processor. So I think in terms of one kind of warning bell or one thing to look out for, that's one that's top of mind for me.
Um, I'm going to finish this live stream by talking about the future and looking ahead. And before we segue into that, I think it's a wonderful segue. Is a question that's come from our audience, Glenn. This one is: if you were designing a greenfield warehouse today, would you still install fixed barcode scanning infrastructure everywhere, or would you build around AI vision from day one? And what technical limitations may prevent that today?
Yeah, so I think this is kind of an interesting topic. If you look at how cameras operate versus how traditional barcode scanning operates, um, I think there are opportunities probably for both. And I think what we're going to see as we look out into the future is probably this combination of both, where you are capturing the image information, you're extrapolating barcode data, but you can also capture the image of the item itself. And this starts to create these additional areas where you can track the condition of goods as they arrive to you and in your facility and as they left, for documenting damage claims, things like this. I do think there is a tremendous amount of efficiency with barcoding as it operates today, that is well worth considering. And I think kind of like as we were talking about RFID at the start of the discussion here, I think a lot of times we're going to see complementary technologies as opposed to exclusionary technologies. So I think that's kind of how I'm seeing the technology develop.
And again, with sort of forward-looking focus, what's the future of intelligent data capture looking like? Is scanning becoming a much bigger part of you could say a much bigger operational intelligence platform? How do you see that playing out over maybe the next 2 to 5 years?
Yeah, I think so. One of the things that is really interesting with implementation of AI, it starts to open up new capabilities. So I mentioned kind of object recognition or item ID. One of the things that is really interesting is the capability with modern models of doing things like image enhancement. So you can take a very low quality image and improve that quality in very predictable ways. One of the other things that we're seeing improvement is around optical character recognition, and previously this has been largely tied to defined code. So if you look at your passport, for instance, it has a very predefined font for optical character recognition using these traditional mechanisms. And there are a lot of problems to be solved, such as orientation and identifying the difference between zeros and O's and so on, right? When you're trying to pull out this type of data. But I think this is one of the other areas where we're starting to see those capabilities emerge for now you've got redundancy and you've got verification. If you can look at the barcode data for the serial number, you can also look at the font data for that serial number. Now you've got redundancy and verification that's starting to open up new capabilities. So these are some of the areas that I think we're actively looking at for continued enhancements here.
Um, so, would you say in the future that the scanners will become more of sensors as much as anything else? With maybe just more than vision as their capability.
Yeah, certainly for image capture. Um, Basically, I think everyone we're looking at data as the new oil, and if you can capture more data in your operations, I think that is big. If you can start extrapolating and capturing not just the one barcode you're looking for, but all four or five of them on the package at one time. If you can start saying, I want to output this data in this order, if you can say I want to capture an image of the item as I'm operating, all of these things are very much you have edge intelligence for your core workflow, but you've also got data capture that is feeding into your backend systems that you can then use to mine for additional operational improvements. And yeah, certainly there is a strong sensor element to what we're talking about.
Well, I'm looking across now. I think I've just got one more question that's just come in. Let me have a look and see. Um, right, yes, it is from Islam. The question is, what's the biggest barrier preventing AI scanning systems from replacing traditional scan workflows?
So that's yeah, good question. I think in terms of the capabilities, the question is what are you trying to accomplish with this, or what are the capabilities? So if you look at traditional barcode scanners, I think we're seeing those AI technologies, the AI capabilities being implemented now. So you're looking at increased capabilities for these devices. If you're looking at kind of a vision system implementation for some of those workflows, I think a lot of those technologies are maturing now as well. So in terms of core barriers, I think those are largely coming down, and you are seeing complementary technologies for AI, integrated AI, machine vision, and barcode scanning.
Well, that was a great question, and we're gonna finish on that. That's really good of you to ask that. It's a great answer as well, Glenn. Kind of want to just say a key, from my perspective anyway, a key message that we can take away is that it seems very much that although we consider barcode scanning like a very mature technology, which indeed it is, it's certainly not standing still. It's not AI is not going to exactly replace the fundamentals of scanning, but it's going to make that data capture more accurate, consistent, and I'm going to use the word resilient because we use it a lot in supply chain, in actually very challenging environments. We've also looked at why organizations should focus on the metrics that really matter. Things like first pass read rates, reducing no reads, and Glenn, you described very well, the negatives around all of that, but also ensuring reliable data. And also we've looked ahead to a future where we see intelligent data capture extending well beyond just simply reading a barcode. It's an exciting area of development, and one which we'll no doubt be following very closely here at Logistics Business. So it just remains for me to say thank you to you, Glenn Aspenns of Honeywell Productivity Solutions. Thank you, Glenn, for joining us. And
Thank you very
for
much for your
sharing.
time today, Peter.
It's a great pleasure, and for sharing your insights and expertise, and to all of you out there for joining us and for your excellent questions. We hope you found today's live stream informative, and that it's given you plenty to think about when considering the future of AI in industrial data capture. Thanks for watching, thanks for listening, and we look forward to seeing you again at another Logistics Business live stream. Thanks, and bye-bye.